Myself, Shivshankar Reddy. I'm from Aero B section. Subject Aircraft Production Technology. Topic Spring Bend Animation of Viscoelastic Materials. Viscoelastic materials such as the uncooked white of an egg exhibited both viscosity and elasticity. You can see the egg white's viscous character when cracking an egg into a frying pan. The egg white spreads to the threads to maintain the deformed shape. The residually egg white reacts up into the shell's remains, showing its elastic character as tight to recover the original shape. Chewing gum is another example of viscoelastic material. Chewing gum includes a gum base, a biocompatible polymer such as a elastomeric that lets the gum stretch elastically. However, the elastic tension gradually attenuates, revealing the gum's viscous character. We can model viscous fluid behavior through two approaches. In one approach, we treat the material such a continuous body and the material's composition in its of little concern. An examples of the approach in this Navier-Stokes equation for a water in which detailed information such as a hydrogen bonds between molecular of bromine motion are not considered. Instead, that materials characters are represented as a set of parameters in the equation, and the solutions describes the materials microscope behavior. The other approach involves particle based fluid simulation, in which the materials behavior is stimulated by moving particles and their interactions. The advantages of particle based simulations is the low cost of calculations. Here we present a particular based animation methods of viscoelastic materials. All polymer materials such as proteins, fats, plastics have viscoelastic characters. Such as materials are composed to intertwined polymer chains. The collision force between particles is approximated by the gradient of the particles density field. Viscosity is represented by the amount of twinning between particle chains. We can change the viscoelastic differently by cutting the connections of reducing the amount of twinning between the polymer chains. We implemented our approach using Microsoft Model 3.0, although Barktail or O'Brien have previously proposed animation methods for a viscoelastic fluids. The animation is based on a continuous body calculation using the Navier-Stokes equation. For more informed on other approaches, see the related work. Their methods is not suitable for time calculation. We promise that the interactive animation scheme specifically for viscoelastic materials based on a particular system. Research in the polymer chemistry field have studied viscoelastic basic. It is a remarkable characters of polymer material. Chemists use this character to calculate the microscopic quantity of polymer material from its microstructures. Polymer material consists of several polymer chains which are formed by combining molecules. Polymer chains randomly interview to form polymeric materials such as rubber, oil, and fat. The randomness results in a conformation that's far different from regular meshes such as a metal and crystal. Analyze viscoelastic based on a molecular structure is difficult due to the kinetic system's complete. Therefore, Rose's development an idealization model for polymers such as a Rose Springs dead model. The model for polymer chains assumes that a single polymer chain has a particular interconnected one dimensionally. By spring force, see figure 1. Furthermore, Russian model assumes that the polymer chain consists on a n segments and chain that each segment may or may not be represent that molecule itself. The number of segment is a small. The polymer chain serves as a decreation of the spring mass system. Historically, this model can characterize the polymer materials microscopic quantity. For example, the sample model provides a good explanation of the elastic models depends on the strain frequency. Since the introduction of Rosie's spring bed model for them 50 years ago, research has been concentrated on analysis using statically dynamics. Now that is possible to simulate motion of particles in a rare time. It is finally possible to simulate Rose Springs dead model directly. The original spring bed model does not consider intervening polymer chains because the model was proposed to dilute polymers. Therefore, the simulated material without modification act as a fluid. We cannot model integrated polymer chains by intersecting an additional spring force between particulars. The amount of pins control the degree of viscosity. The concept of analogies, the vacuolization of rubber, whereby the raw fluid snap from the rubber tree is converted to solid rubber by connecting polymer chains with sulfur. This process increases the fluid's elastic, causing the rubber to act as a solid material. As shown in figure 1, resist models divides a single polymer chain into the subsections. Such a subsection is replaced by beds to represent friction. Mass and volume springs connect the neighboring beds of to representing rubber-like behavior for a small elongation. The spring also work as a discrete points of resistance to flow viscosity by considering a frictional force. In polymer chemistry, Rossi's model derives the number of configurations available for the chain. We use probability density function to calculate the material's entropy. The probability density is a proportional to the number of configuration. For example, it's a rare for a Betz Algerian straight line because only for configuration can realize that situation. In other words, it's commonly for everyone.